Hi everyone and welcome to episode 20 of our ConfigMas 2022. My name is Johan and in this demo you will learn how to speed application deployments in ConfigMgr. It's primarily two things to it, or two things I will demonstrate here. One is to embrace a little bit of peer-to-peer, and the second one is to create better packages in ConfigMgr. And that means demo time. So, starting with peer-to-peer. Here I have a blog post and I will share the link in the description below, but this one covers the various peer-to-peer technologies that Microsoft offers. For ConfigMgr traffic or for ConfigMgr packages, only peer caching and branch cache is supported. Of the two, this one is in general the better one, it's more effective, but I will showcase both in this one. As you can see, there are links to step-by-step guides for each of these technologies, and I'm going to give you a 2-minute crash course now. If you want to learn a little bit more, we do have a free mini course where we spent an hour and a half going through more details and more in depth about all these different technologies. But for now, let's get over to my ConfigMgr server. First, what I have here is a few different locations. I have some machines in Chicago, and I have some machines in Seattle, and I have a ConfigMas environment. So basically, I have something like this, where this branch office is supposed to be either Seattle or Chicago. Shorthand version is I have machines that are remote to the distribution point. They are on the sort of wrong side of a WAN link. And I can assure you it's way more effective from a speed perspective, from a network perspective, to have each client share content to each other so that only one needs to get it from a distribution point, compared to having every single client reaching over the WAN link to get content. So that's obviously peer-to-peer in a nutshell. Now, for peer cache, what you need to do in ConfigMgr is that you need to designate something called peer cache sources. You need to dedicate a few machines on every location that you designate as the first to have the content in their cache. And in this case, I have a client setting that I have configured. It's called peer cache. And I have enabled peer cache on it. And I have also bumped up the cache size because peer cache is using the ConfigMgr client cache. This one I have deployed to my peer cache sources collection. And as you saw earlier, these are my clients there. The clients in this collection must be pretty much online at all time, because peer cache starting with ConfigMgr 1806 will only return sources that are online as far as ConfigMgr is concerned. So the way this works is that every time a peer cache source is downloading something, it will report that something up to ConfigMgr, so that ConfigMgr knows where content is. So when there are other clients, in this case in Seattle, that is asking for content, these two machines will be returned as distribution points, even though they are definitely not distribution points. The way this looks on the server side is that if you go into the database, you can ask, for example, for, hey, give me all peer cache sources in the environment. Or give me all peer cache sources with some names that also have some content. Now, the challenge is when the client cache and the server information becomes invalid or mismatched, you may actually have sometimes to go in and clear out the information in a database even though you're not really supposed to. There is a nifty little tool that Nathan Sune put together back in the days. It's called the Peer Cache Explorer. But in this tool, you'll see your different peers. And you can also click a specific package and you can see which peers that happen to have that package. So, pretty useful tool. BranchCache, on the other hand, works on a block level and it doesn't require the entire file to be downloaded to a client first. So you don't technically need to specify or dedicate sources or caching machines out there. You can, but you don't have to, like you absolutely must with peer cache. As a little example on the difference between these two technologies is that Over here, I wrote a blog post back in about 2 years ago. I was comparing different compression algorithms and how they worked with the BranchCache protocol. And to give you an example, I was having a bunch of different driver packages that I was testing with because they're good to test with. And when compressing them with different compression algorithms, what we found, or what I found, was that when using Vim files, even though these packages were like 30 gigs from the beginning or 32 gigs on the server side, when transferred over the network, they were only about 8. And when stored in the cache, there were only about 8, because BranchCache is using data deduplication, and among all these different driver models from, in this case, HP, on a block level there were many identical blocks. Peer cache, however, you would have to cache everything. You have to download everything over the network, and you have to save that space in the cache as well. So BranchCache in this case was like 75% more effective. Now, if working with BranchCache, the only thing you really need to configure is to enable your distribution points to be BranchCache enabled. So if I go to my DPs here, I can show you one of them. Properties, and enable BranchCache. Then you need to configure the clients, and you should absolutely not use client settings in ConfigMgr. They have not been updated in a decade or so. You should also not use group policies because there are settings, critical settings that are missing there. What you should be using is instead a configuration baseline that simply takes care of configuring the BranchCache settings on the client. And that's typically called to have a BranchCache Tuner. And I will show you an exported baseline that you can import in your environment. But this one, making sure that you have the right cache size, that you have the right port, that you have the right time to live value, and basically set up BranchCache well on the client side. Now, if I will go to one of my machines in Chicago, I'm going to wipe the cache to make sure I don't have any content at all. And I'm going to do the same thing on my second client. Now, if I go back to client number 1, I'm going to head and download one of my packages and wait until that completes. Package is downloaded. I can now query the event log to get some information about that download. ConfigMas is downloading its content using bits. So in here, I can ask for the last downloaded job. And it will tell me that it downloaded this package. And as you can see here, pretty much all of the content came from a DP where basically nothing came from a peer. The reason we see anything at all in here right now is because of data deduplication. Now, if I go up to my second client, and I have wiped the cache already, and I'm going to download the same package. Package is downloaded. Going to check the event log. And sure enough, this time every single byte came from a peer. Now, obviously, this scenario, the more content you can share between peers, the quicker everything goes, and the more you will reduce over your WAN link. Now, over to the second part, creating better packages. Over here, I will have a pretty good example. I have an Autodesk application, 3D Studio Max. This application by default is about 4 gigs in size, and it has almost about 18,000 files. If I instead create a Vim file of the same folder, you can see it's a single file, and it's only 1.6 gig in size. And I can assure you, it's way quicker in ConfigMgr to download a single file of 1.6 gig compared to 18,000 files and 4 gigs. And don't get me started on the peer-to-peer efficiency, or if you're doing HTTPS deployment, or if you're downloading from a cloud management gateway. You can see that this download maybe take just a few minutes, whereas this one can take 40 minutes. So compressing them into WIM files is a great improvement. In its simplest way, it can be something like this. If I go over to my config manager server, and let's see here, demo, application as WIM files. Here is a simple script that takes a folder with a package and creates a WIM file out of it. And then I have another example here that actually installs it. So first some variables, then during deployment I will mount the WIM file, install the application, and dismount the WIM file again. Simple, you don't need to extract anything, you can just mount the WIM, it's almost instant, and you will find it goes much quicker. There are several good blog posts out there. Here is one from Sune Thomsen, highly recommended. I have one here from Justin Holloman, and I have another one here from Dylan Brown. And I will share a link to all of these under the video here in the description. But they all go into basically the same concept. You have some way of creating the WIM file, and then you have a script that actually deploys it. And that was all for today. I hope to see you again tomorrow. Thank you so much for watching. Bye for now.